Have you ever looked up at the night sky and wondered, where did it all begin? How big is the universe? And what forces are at work beyond what we can see? In this video, we'll explore three of the greatest cosmic mysteries ever known: the Big Bang, dark matter, dark energy. Together, they tell the story of a universe that is not only vast and ancient, but still evolving, still expanding, and still keeping secrets. To understand the universe, we have to go back in time, way back, over 13.8 billion years ago. Back then, there was no space, no time, no galaxies, no stars, just a singularity, a point smaller than an atom, yet containing all the energy of the cosmos. In a moment too quick to comprehend, it began. The universe expanded rapidly in an event we call the Big Bang. It wasn't an explosion in space, it was the explosion of space itself. In fractions of a second, space expanded faster than the speed of light. Matter and antimatter collided, releasing energy. The laws of physics began to take shape, and the building blocks of everything, protons, neutrons, electrons, were born. The universe was a hot, glowing fog of particles, too hot for atoms to form, too dense for light to travel. But about 380,000 years later, the fog lifted. The universe cooled enough for atoms, mostly hydrogen and helium, to form. Light was finally free to travel, creating a faint glow that still surrounds us. The cosmic microwave background, the oldest light in the universe. Over millions of years, gravity took hold. It pulled atoms into clouds, clouds into stars, and stars into galaxies. The universe wasn't and that structure would soon reveal a deeper mystery. When astronomers observed distant galaxies, they noticed something strange. The stars on the outer edges were moving far too fast. According to gravity and visible mass, those stars should have flown off into space, but they didn't. Something invisible was holding them in place. That something was given a name: dark matter. It doesn't emit light, it doesn't absorb it, we can't see it, but we can see what it does. It acts as a kind of cosmic scaffolding. It surrounds galaxies, holding them together. It warps space, bending light in ways that reveal its presence. In fact, about 85% of all matter in the universe is believed to be dark matter, ordinary matter. Everything we can see is just a small fraction. So what is it? Some believe dark matter is made of exotic particles, WIMPs, axions, or sterile neutrinos. Others think it could be black holes, strange compact objects, or even an entirely new form of physics. Despite decades of searching, we still haven't caught one. But without dark matter, galaxies wouldn't form. And without galaxies, there would be no stars, no planets, and no us. If dark matter holds the universe together, dark energy is tearing it apart. In the 1990s, two teams of astronomers observed something unexpected. They were studying distant supernovae to measure how fast the universe was expanding. The results shocked them. Not only was the universe expanding, it was expanding faster than before. This defied everything we thought we knew. Gravity should be slowing things down, but something, an unknown force, was speeding it up. That something was named dark energy. Today, we believe dark energy makes up nearly 70% of the universe. It's everywhere, in every point in space, and it's pushing galaxies away from each other with increasing speed. We don't know what dark energy is. It could be Einstein's cosmological constant, a property of space itself, or it might be a dynamic field that changes over time. Whatever it is, it controls the fate of the universe. So where does this all lead? What will happen to the universe in the far future? Cosmologists have explored three possibilities. 1. The Big Freeze, where the universe expands forever. Stars die, galaxies drift apart, and the cosmos becomes cold, dark, and empty. The Big Rip, where dark energy grows so powerful it tears galaxies, stars, and even atoms apart. 3. The Big Crunch, where gravity eventually reverses the expansion, pulling everything back into a single point. Current data suggests we're heading toward a big freeze, a universe where expansion never stops. Galaxies will vanish from view, stars will go dark, and after trillions of years, black holes will evaporate, leaving behind silence. But in that silence lies beauty, because it tells us just how precious this moment is. We live in a universe born from fire, held together by darkness, and driven apart by energy we barely understand. The Big Bang gave us time, space, and matter. Dark matter shaped that matter into galaxies. Dark energy stretches those galaxies toward the unknown. Yet here we are, tiny, fragile beings on a small blue planet, trying to understand it all. We map the stars, we build. We ask questions no one ever dared to ask. And every answer leads to a new mystery. Dark matter, dark energy, the Big Bang. They're not just concepts. They are clues, telling us that the universe is more complex, more beautiful, and more mysterious than we ever imagined. And perhaps, in understanding them, we'll understand a little more about ourselves. The universe is expanding. Let our curiosity expand with it.